More than a century of diagnostic radiology in the Netherlands. The 19th century was the century of electricity. The German physician Hopf wrote a fairy tale about it, Electra. Oh, if I knew a way to make people as transparent as a jellyfish, then everything would be fine. 3 years later it happened. But what does Röntgen have to do with the Netherlands? He was raised in this house in the Dutch town of Apeldoorn, of which he laid the cornerstone as a 5-year-old. For his secondary education he went to the Dutch city of Utrecht, where he boarded with his chemistry teacher Gunning at the Nieuwe Gracht. A tile picture on the outside of this house, an initiative of the Historical Committee of the Radiological Society of the Netherlands, is a reminder of his stay here. A subsequent university education was not possible in the Netherlands of that period. He therefore went to study in Zurich in Switzerland. He got his PhD in 1869 and met his future wife Anna Bertha Ludwig there, and he married her in 1872 in Apeldoorn. At the end of 1895, Röntgen surprised the world with his discovery. Many scientists immediately reproduced his experiment, also in the Netherlands. As early as January 1896, the physics teacher Hofmans in Maastricht experimented with Röntgen rays and published his results. Physicist Kamerink recently reproduced Hofmans' methods using the original instruments that have been conserved. In 1898, the first X-ray departments were founded in the Netherlands, such as in Amsterdam, Maastricht and, as shown here, in Haarlem. A year later, the neurologist and electrotherapist Wertheim Salomonsson in Amsterdam was appointed extraordinary professor with partial assignments including, amongst others, electrotherapy and röntgenology. He was one of the founders of the Netherlands Society for Electrotherapy and Röntgenology. It was, however, Wenkebach, the well-known professor of internal medicine in Groningen, who, with his instantaneous exposures, stereo techniques, and an adapted, self-designed radiographic stand, gave the X-ray photograph a place in the hospital. In 1908, he presented his results at the important 4th International Congress of Röntgenology in Amsterdam, which he had organized together with Wertheim Salomonsson. In the meantime, the physicists Haga and Wind in Groningen had provided evidence for the wave character of the X-rays and had determined its wavelength. Röntgen complemented them with their results. Because of his study, Wind became an early X-ray martyr. He died at a young age of serious anemia. In medicine, the instantaneous exposures made the difference. In 1910, the Dutch pioneer Pieter Hendrik Eijkman was successful in recording the first X-ray movie of the heart, using the so-called X-ray flash apparatus. Other moving parts of the body, such as the stomach, which was focused on by internist radiologist Voorhoeve, and the skull that was studied by neurologist Stenvers. Their names still live on as eponyms in the world literature. The more modern X-ray department was established in the various hospitals around the 1920s. An important contribution to this was made by the Philips factories in Eindhoven. There, the young physicist Albert Bouwers developed the Metallics X-ray tube, designed to provide full protection against high voltage as well as undesired X-ray exposure. In 1928, he was awarded the RSNA Gold Medal. In the 1930s, neurologist Zietses de Plantes developed the tomography technique, which he himself called planography, as well as the subtraction method. He received many international decorations. The first medal for tomography of the German Society of Neuroradiology, which bears his name, was awarded to the computed tomography pioneers Oldendorf on the left and Hounsfield on the right. Before the Second World War, there was only one Dutch professorship in radiology, in Amsterdam. Thereafter, the number increased quickly, partly as a result of the 4 newly founded university hospitals. Dutch radiology expanded enormously. The Utrecht professor Puilaert used to talk about this period full of enthusiasm. The expansion was tool-driven and followed the development of the radio valve to the transistor, the microchip and the computer. Partly due to this, image intensifier tubes and TV change took over the X-ray rooms. a host of new contrast media enabled new types of examination, with the emphasis on gastrointestinal examinations, angiography and bronchography. In addition, mammography was introduced. In the 1970s, diagnostic radiology was reinvented. The classic radiography, using projections, was forced to the background, as ultrasonography, computed tomography, and magnetic resonance imaging entered the scene. Interventional radiology was introduced as well. Further specialization became necessary in 10 subspecialties, including neuroradiology, abdominal radiology, and pediatric radiology. And furthermore, nuclear medicine was reunited with radiology as one discipline due to imaging modalities such as PET-CT and PET-MRI. Since the 1950s, the number of scientific publications in all fields has doubled every 9 years. Radiological publication numbers increased exponentially as well, such as the number of dissertations. Many people contributed to the growth of the radiological discipline. While the 19th century was characterized by developments in electricity and the 20th century by those of computers, we expect the 21st century to become characterized by informatics, the new language of science. The fairy tale Elektra predicted Röntgen's discovery. Who will write the fairy tale Informatica?